Hello everybody. Today we are going to learn about a vector. In vectors, first we learn representation of a vector. Next, laws of vector, vector addition, and then vector multiplication, and then resolution of vectors. Based upon this concept, we are going to solve problems. Then after we are going to learn problems from the previous question papers, and then assignment, worksheet. These are the things we are going to do in vector section. Okay, let us start vector. The physical quantity which can be represented by both magnitude and direction is called a vector. If you say velocity, it is a vector quantity. A body moving with 72 km per hour towards south. 72 km per hour is the magnitude and direction south. Such a type of representation of a physical quantity is called vector. First we go for how we can represent while writing representation of a vector. By a letter, we can represent a vector by any letter. Say A vector, letter with arrowhead. P vector, likewise we can represent by a letter. Next, by geometry. A straight line with the arrowhead. OP is the straight line with the arrowhead. It may be 5 Newton or 10 Newton. The length of the line OP gives magnitude of the vector, arrowhead gives direction. Likewise, if you want to represent 10 Newton force, you must draw a line whose length is double that of OP. Say this is O dash P dash. This is 10 Newton force in the same direction of OP. So the length of the vector gives magnitude and arrowhead gives direction. These are the representation of vectors. Next we are going to learn vector addition. How to add 2 vectors, 3 vectors, 4 vectors, like that. First of all, let us learn vector addition. Geometrical vector addition first we learn. 2 vectors we are going to take, A vector and B vector. Both are acting at a point, say O, at an angle theta. This is the representation of these 2 vectors. This is A vector, this is B vector. Both are acting at the point O at an angle theta. How to add these 2 vectors? We are going to see. If you take a vector where it start, that is called the origin of the vector, where it end, that is called a head of the vector, origin and a head, or tail and a termination, we can say. Let us add a vector with b vector. Geometrically how to add we are going to see. Take the first vector. This is the first vector, a vector I have taken. I have not changed the direction. Bring the tail of a second vector to the head of first vector. While bringing the b vector, you should not change the direction. For example, this is the direction of a vector, the dotted line. This is a line of action of a vector. With that line, the b vector should make an angle theta. Shift this b vector to the head of a vector such that tail of b vector should coincide with head of a vector. The b vector should make an angle theta with the line of action of a vector. Okay. The resultant of a vector and b vector. How to draw that vector? Let us see. This is the tail of first vector. This is the head of second vector. Draw a straight line from tail of first vector to head of second vector. It gives a resultant of a vector and b vector that can be represented as a vector plus b vector. Let us take it as c vector. C is the sum of a and b. This line, say OP represent a vector, PQ represent a b vector, OQ represent a resultant of the a vector and b vector. This is the geometrical vector addition, two vectors. First case. Second case. Suppose there are three vectors acting at a point O. This is P vector. This is Q vector. And this is R vector. P and Q makes an angle alpha. Q and R makes an angle beta. We are going to add these three vectors. How to add? First of all, bring the first vector without changing the direction. This is the P vector. This is the line of action of P vector. Bring the tail of Q vector to the head of P vector. Bring the tail of Q vector to the head of P vector without changing the angle. This is Q vector. It makes an angle alpha with P. This is the line of action of Q. Now let us shift R vector without changing the direction. Bring the tail of R vector to the head of Q vector. This R vector makes an angle beta with Q. Three vectors now we have added. How to find resultant of all the three vectors? We have to draw a vector from tail of first vector to head of last vector. Join this line. Join these 2 points by a straight line. It gives P vector plus Q vector plus R vector. In this way, we can add multiples of vectors acting at a point. Bring the tail of a second vector to the head of first vector, and then bring the tail of third vector to the head of second vector. Bring the tail of fourth vector to the head of third vector. Like that you add. Finally, draw a vector from tail of first vector to head of last vector. that gives the resultant of all the vectors. Now we are going to see the triangular rule or triangular law of vector addition. At a given point, there are two vectors acting, A vector and B vector. Let us take. This is A vector, OP is A vector, this is B vector, OQ is OQ is the B vector. Both are acting at an angle theta with each other. They are acting at the point O. Already we learned how to add these two vectors. I draw the diagram once again. This is A vector, line of action of A vector. This is B vector. It makes an angle theta with line of action of A. A vector drawn from tail of first vector to head of second vector gives resultant, that is denoted as C vector. If you see this vector addition, we can get a triangle. In this triangle, OP and PQ are the two sides. These two sides are the magnitudes of the A vector and B vector. So the two vectors are represented by two sides of the triangle in the same order. In this diagram, A vector and B vector in the order anticlockwise. The resultant is represented by third side of the triangle in the opposite order. So what the triangular rule says, if two vectors are represented by two sides of a triangle in magnitude and direction in the same order, then the resultant vector is represented by third side of the triangle in the opposite order. This is the triangular rule. We can calculate a magnitude of C vector in terms of magnitude of A, B and angle theta between them. So we can prove that magnitude of C vector is equal to square root of magnitude of A square plus magnitude of B square plus 2 into product of AB magnitudes and cos theta. Suppose if A vector and B vector act at an angle 0 or in the same direction if they act, then angle between them is equal to 0. Then C magnitude is equal to square root of A square plus B square plus 2AB cos 0 is 1. Then it can be written as square root of A plus B the whole square. Then C is equal to A plus B This is the maximum magnitude of the 2 vector. If 2 vectors act in the same direction, then the resultant is equal to sum of the magnitude of given vectors. Suppose the 2 vectors act at an angle 90 degree. Suppose B vector, this is along y axis, A vector along x axis, then angle between them is 90 degree. If theta is equal to 90 degree, then C magnitude is equal to square root of A square plus B square plus 2AB cos 90, cos 90 is 0. C is equal to square root of A square plus B square. Suppose these 2 vectors act in the opposite direction. This is A vector acting from the point O. This is a B vector acting from the point O against A vector. Then angle between them is 180 degree. In this case, if theta is equal to 180 degree, then magnitude of C is equal to square root of A square plus B square plus 2AB cos 180, cos 180 minus 1, therefore minus 2AB. C is equal to, it can be written as square root of A minus B the whole square. C is equal to A minus B. This is the minimum magnitude of the 2 vectors. If 2 vectors act at a point, then the magnitude may be in between A minus B and A plus B, any value it can be. Another case we are going to take. Let us take the 4th case. The magnitude of A vector and B vector are equal and they are acting at an angle theta. This is the case. If magnitude of A is equal to magnitude of B and angle between them is theta, then magnitude of C is equal to square root of A square plus B square. B square is equal to A square plus 2AB, 2A into A square cos theta. C is equal to square root of 2A square plus 2A square cos theta. C is equal to square root of 2A square into 1 plus cos theta. C is equal to square root of 2A square into 2 cos square theta by 2. 1 plus cos theta can be written as 2 cos square theta by 2. Therefore, C is equal to 2A cos theta by 2. If 2 vectors of equal magnitude act at a point, then the resultant can be written as 2A cos theta by 2. In this case, we are going to learn some sub cases. If theta is 0, 60 degree, 90 degree, 120 degree, 180 degree, these results must be kept in mind to solve problems. These results may be a part of a problem. Let us take case A. If theta is equal to 0, then C is equal to 2A cos 0 1. So C is equal to 2a. If two vectors of equal magnitude act in the same direction, then the resultant magnitude is equal to 2 times of magnitude of any one of the vector. If theta is equal to 90 degree, then C is equal to 2a cos 45. Cos 90 by 2 cos 45, and C is equal to 2a 1 by root 2, C is equal to root 2a. If two vectors of equal magnitude act at an angle 90 degree, then the resultant is equal to root 2 times of any one of the magnitude. Case C. If the two vectors act at an angle 120 degree, then C is equal to 2a cos 120 by 2 60, 2a cos 61 by 2, then C is equal to a. If two vectors of same magnitude act at an angle 120 with each other, then the resultant is equal to any one of the magnitude. Next case, if theta is equal to 180 degree, opposite direction if two vectors act, then C is equal to 2a cos 90, and C is equal to 0. If two vectors of equal magnitude act in the opposite direction, then resultant magnitude is 0. This result must be kept in mind. Let us solve a problem based upon this result. Five vectors are acting in the xy plane at origin, each of magnitude 10 newtons. OP vector, OQ vector, OR vector, OS, OT. These are the five vectors acting in the xy plane. Angle between PQ is 45. Angle between P and R is 90 degree. Angle between T and S vector 45 degree. T and R 90 degree. Okay, all are equal vectors, equal magnitudes, sorry, directions are different. We have to get a resultant of all the five vectors. Okay, this diagram can be simplified. First of all, let us take OT vector and OP vector. OT and OP are equal in magnitude, opposite in direction. Therefore, these two vectors cancel each other. So, this is the line of action of OT and OP. The resultant on this line is 0. This is the point O. So, we need not to bother about these two vectors now, because they themselves cancel each other. Then the above combination of vectors is simplified into only three vectors. OQ, OR and OS. The angle between QR is 45 degree and angle between SR is 45 degree. Therefore, angle between Q and S is 90 degree. Let us talk about these two vectors, OQ and OS. These are equal in magnitude, 10 Newton and 10 Newton. Angle between them is 90 degree. So, resultant of these two vector is equal to root 2 times of any one of the magnitude. That resultant will bisect the angle 90 degree. If it bisect the 90 degree angle, it will be along OR vector. So, this diagram can be simplified into two vectors. Actually, OR vector is acting along y axis. The resultant of OS and OQ will act along OR. That magnitude is equal to root 2 times of any one of the vector, root 2 10 Newton, OR is equal to 10 Newton. Okay, these two vectors are acting in the same direction. One magnitude is 10 Newton, another magnitude is root 2 10 Newton. So, if two vectors act in the same direction, then resultant is equal to sum of the magnitudes. So, the resultant of these two vectors is given by ten plus 10 root 2. So, that is equal to 10 into 1 plus root 2 Newton. That is equal to 10 into 1 plus 1.414 Newton. That is equal to 10 into 2.414. That is equal to 24.14 Newton. This is the resultant of all the 5 vectors. So, already I taught a concept, some tips. If two vectors of equal magnitude act at an angle theta, then resultant. 5 cases we have learned. If theta is 0, 60, 90, 120 and 180. These 5 subcases result, if you keep in mind, that result can be applied in a problem and the time will be saved. You should not solve once again c is equal to 2a cos theta by 2, you should not derive all these values. After practicing it, you have to keep in mind the results. Okay, based upon the above result, let us solve another problem. Second problem. 3 vectors of equal magnitude act at a point. Say OP vector, OQ vector, OR vector, all are 50 newtons. Angle between successive vectors 120, 120, 120. Then what is the resultant? We are going to see. First of all, let us take OP and OQ vector. These two vectors act at an angle 120 with each other. If two vectors of equal magnitude act at 120, then resultant is equal to any one of the magnitude, and the resultant will bisect the angle 120 degree. So this is the R vector, 50 Newton. I am going to consider the resultant of OP and OQ. These are OP and OQ vectors at an angle 120 degree. The resultant of these two vectors will bisect this angle 120. Resultant magnitude is equal to magnitude of any one of the vector. Newton. This is the resultant of OP and OQ, that 50 Newton will act opposite to OR vector. If two vectors of equal magnitude act in the opposite direction, then the resultant magnitude is 0. Okay. Let us take another problem. Four vectors are acting at a point. This is 50 Newton, OP, OQ. Is 50 Newton. OR 100 Newton. I could not draw the length of OR double that of OP due to constraint, space constraint. Let us consider this is 100 Newton and this is OS also 100 Newton. Let us take opposite vectors OP and OR. Two vectors are acting opposite direction, magnitude 100 and 50. The resultant of OP and OR is 50. 100 minus 50 is equal to 50. If two vectors act in the opposite direction, resultant is equal to difference of magnitude of the two vectors. That resultant will act along the greatest vector magnitude direction. So OR is 100, greatest magnitude compared to OP. So that the resultant of OP and OR will act along OR. That resultant is 50 Newton. Let us take these two vectors OQ and OS. These are opposite two vectors acting in the opposite direction. So resultant magnitude is difference of magnitude of the two vectors, that is 50 Newton. That will act along the greatest direction magnitude, greatest magnitude vectors direction. Now these four vectors are simplified into two vectors, 50 Newton and 50 Newton, both are acting at an angle 90 degree. If two vectors of equal magnitude act at 90 degree, then resultant is equal to root 2 times of any one of the magnitude, root 2 50 Newton. That will bisect the angle 90 degree, 45 with both vectors. This is the resultant root 2 15 u. Dear student, now we are going to learn subtraction of two vectors, vector subtraction. Vector subtraction can be done in the same way that of vector addition. How we are adding two vectors, in the same way we can do the subtraction also. Let us take a vector and b vector. They are acting at an angle theta. This is a vector, b vector. A vector and b vector are acting at an angle theta at a point O. We are going to subtract b vector from a vector. What is the resultant of a vector minus b vector? That we are going to see. If you reverse the b vector, that gives a minus b vector. This is minus b vector. We are going to add a vector with minus b vector. That is the subtraction of a vector and b vector. Now the angle between a vector and b vector is 180 degree. We are going to calculate a vector minus b vector magnitude. We can follow the same principle or method for vector addition. Take this a vector, don't change the direction. This is a vector represented by OP. Bring the tail of minus b vector to the head of a vector. To find the resultant of a vector minus b vector, draw a vector from tail of first vector to head of minus b vector. OQ gives a vector minus b vector magnitude. So subtraction also can be done the same way that of addition. In this case, the magnitude of resultant a minus b, I take it as a c vector. Magnitude of c is equal to square root of a vector plus b vector plus 2ab cos of angle between a vector and minus b vector, that is 180 minus theta. In this case, we can get magnitude of resultant is as a square root of a square plus b square minus 2ab cos theta. We can see cases. Case 1, if two vectors a vector and b vector act in the same direction, then what is the a vector minus b vector magnitude? We are going to see. If theta is equal to 0, then magnitude of c is equal to square root of a square plus b square minus 2ab cos 0 1 minus 2ab. C is equal to square root of a minus b the whole square. C is equal to a vector magnitude minus b vector magnitude. Second case, if a vector b vector act at an angle 90 degree, Then what is the magnitude of a minus b vector? Then c is equal to square root of a square plus b square minus 2ab cos 90, cos 90 is 0. Then c is equal to square root of a square plus b square. Third case, if two vectors act in the opposite direction, a vector, b vector act opposite direction, then what is the magnitude of a minus b? Theta is equal to 180 degree. Then c is equal to square root of a square plus b square minus 2ab cos 180, cos 180 minus 1, therefore minus 1 into minus 2ab plus 2ab, and c is equal to square root of a plus b the whole square, then c is equal to a plus b magnitude. Let us take the fourth case now. We come to the fourth case. If two vectors of equal magnitude act at an angle theta, then what is the resultant of a vector minus b vector? Magnitude of a vector and b vector are equal and the angle between them is theta. Then magnitude of a vector minus b vector let us take it is a c magnitude. C is equal to modulus of a vector minus b vector is equal to square root of a square plus b square also a square plus 2 into a b minus 2 into a b, that is 2a square cos theta. Then c is equal to square root of 2a square minus 2a square cos theta, and c is equal to square root of 2a square into 1 minus cos theta. C is equal to square root of 2a square into 2 sin square theta by 2. And C is equal to 2a sin theta by 2. This is the magnitude of resultant of two vectors of equal magnitude act at a point at an angle theta. If one of the vector is reversed, then the resultant magnitude C is equal to 2a sin theta by 2. Here also we are going to see 5 different sub cases. If theta is equal to 0, then C is equal to 0. If theta is equal to 60 degree, then C is equal to 2a sin 30 and C is equal to a. If theta is equal to 120 degree, then C is equal to 2a sin 60, that is equal to 2a root 3 by 2, that is equal to root 3a. If theta is equal to 180 degree, then C is equal to 2a sin 90, C is equal to 2a. We have to remember all these cases. We can come to a conclusions from this result and a previous A plus B magnitude result. At an angle 90 degree, A plus B magnitude and A minus B magnitude are equal. So we have not done for theta 90 degree. Okay, we go for theta 90 degree. If theta is 90 degree, then C is equal to 2A sin 45, then C is equal to 2A into 1 by root 2, that C is equal to root 2 times of any one of the magnitude. From this result we can conclude magnitude of A vector plus B vector is equal to magnitude of A vector minus B vector. If angle between them is 90 degree. If modulus of A vector plus B vector is equal to modulus of A vector minus B vector, then angle between A vector and B vector is 90 degree. Let us learn a problem based upon the vector addition. This is problem number 4. In this diagram, this is A vector, this is B vector, this is C vector. This is D vector and this is E vector. A, C, E vector are acting from the point O. This is horizontal. Tail of B vector act from the head of A vector. Likewise, tail of D vector act from the head of A vector. These are the vectors. If we see this diagram, tail of B is at the head of A. So, you see this triangle OPQ. In OPQ triangle, OP and PQ are the two sides of the triangle. Two vectors A and B are represented by these two sides of the triangle. Therefore, C vector must be the sum of A vector and B vector. This is what we concluded from the diagram. C vector is equal to A vector plus B vector. Likewise, let us see this diagram triangle OPR. OP and PR are the two sides of the triangle, and A vector and D vectors are represented by these two sides of the triangle in the same order. Then OR represent resultant of A vector and D vector. Therefore, E vector can be written as A vector plus D vector. The question is, what is the sum of C vector and E vector? This is one of the question. So, sum of these two vector is equal to, from the result we can write A vector plus B vector plus A vector plus D vector, that is equal to 2A vector plus b vector plus d vector. Another question is asked, what is c vector minus e vector? In this case, we can write c vector as a vector minus plus b vector minus of a vector minus d vector plus d vector. A minus a is 0, so b vector minus d vector. This is a problem based upon vector addition.